Okay, so this is a lesson that's going to continue yesterday's lesson on determining whether functions were one-to-one, and also talk about transformations of functions. Your homework tonight is a worksheet. There are two parts to it. The first side says determining whether a function is one-to-one, and the back says transformations of functions. I want everyone right now, get out your worksheet. Add to the front. If it is not one-to-one, you must give at least one way of modifying the domain of the function so its inverse is a function. What I would like you to do, once you've done that, is to start this warm-up. I would like you to please graph. You don't need to use graph paper. You can use regular paper in your notebook. Graph these three functions. If you need to use your calculator to help you, for number 3, you may. Number 1, you should not need a calculator. Number 2 is a maybe. Okay, so if you need more time, pause the video, and we're going to graph these functions, determine if they are one-to-one, and if they are not one-to-one, we're going to modify their domain. So we see the first function is an absolute value function. Its vertex will be at -5, 0. So 1, 2, 3, 4, 5, 0. It's got a slope of 1 because there's like a is 1 here. So it would go up 1 and right 1. And there's the symmetric part. So we can tell from looking at this that this is not one-to-one. Okay. Now, this part we will do together. Modify the domain of the function so its inverse will be a function. So all you need to do for these functions is look at the symmetric point. Look at the vertex and kind of cut the graph right there. If we only used 1/2, either the left side or the right side, the graph would be one-to-one. So the new domain could be x is greater than or equal to -5, or you could use x is less than or equal to -5. Either one would be fine, because then just if you only had half the graph, it would be one-to-one, and its inverse would be a function. So number 2, if you use your calculator, has a vertex of 1, 3. And it's a parabola. It opens up like this, and it is not one-to-one. So again, we need to take this graph and cut it at its symmetric point. The symmetric point is the vertex. It's the same name as an absolute value function. And here we can make the domain x is greater than or equal to 1, or you could use x is less than or equal to 1. So for our last function here, f of x equals x cubed, we have a cubic function. If you graph it on your calculator, it looks kind of like this. And yes, it is one-to-one. And we can tell that because every y value only appears once. There you go. Right now, we're going to pause the video in a second, and you're going to get your quizzes back. I want to talk about the reassessment. It will be Monday at lunch. If you cannot do Monday at lunch because you have an existing commitment, as in you have already made plans with another teacher, you need to send me an email so that we can find another time for you to do it. Please make sure you understand that this is prior. You have already made plans for Monday at lunch with another teacher. To be eligible for the requiz, you must do the following. And if you do not do any of these, you will not take the requiz. On a separate sheet of paper, you need to redo any problem you do wrong. Make sure you have it done correctly and you understand how to do it. If you have extra practice papers stapled to the back of your quiz, you must do every single problem on those papers and hand them in. And I will know, based on your mistakes, if you have removed any of them. These are skills you should have learned in Algebra 1 or in middle school. That says Tuesday. Bring the redone problems, your extra practice work, and the original quiz to the requiz on Monday. I want to remind you that the new requiz grade replaces the original quiz grade, even if you score lower on the requiz. And that will be a conversation you and I have if, for some reason, you score lower. On Friday at lunch, tomorrow, I will do a complete reteach of this quiz. I will go through it question by question. If you scored 50% or lower, you must attend at lunch or give me a reason why you are not. And again, that reason needs to be, I am meeting with the following teacher, not I have to watch film or I have a club meeting. So go ahead and pause the video until all the quizzes are returned. Okay, so the answers to last night's homework have been on Edline, so I'm not really going to leave those up for too long. You can check Edline to get those answers. Hopefully it was a pretty easy assignment. All you had to do was figure out if things were 1-to-1. And then for the back, here are what the sketches looked like. And honestly, guys, I just found some points. Like here, I found the point at 4, 2, and I switched it to 2, 4, and I just graphed a bunch of inverse points. Like here, I kind of put a point here, and I found its symmetric point here. Same thing. So here are what the graphs would have looked like. And you can see here I even made a table. Okay. Today we're really talking about transformations of functions. Again, you need to make sure you modify the directions to the front of tonight's homework. Every transformation takes the following form. And those of you who use different colored pens, I want you to note the pen color. So every function takes the form f of x equals a, and then the function, so whatever you're doing to the x value, absolute value, square root, squaring it, f of x minus h plus k. From absolute value functions, take a minute and think about what you know about a, h, and k. This is also where you would write down this formula if you haven't already. Okay, so from absolute value functions, we remember that a, if it's less, if a is negative, it can reflect over the x-axis. It can also make it wider or thinner, depending on the value. Like if it was 2, positive or negative, it would be thinner. And if it was something like 1/3 or 2/3, anything between 0 and 1, the graph becomes wider. We remember from absolute value functions that h shifts the graph left or right, the opposite of what it seems, because the negative is part of the formula. So if it's x minus 4, it's actually going to go to the right 4. If it's x plus 4, it's actually going to go to the left 4. And from absolute value functions, I hope you remember that k shifts the graph up or down exactly as it is, exactly as it looks. What we're going to do is we are going to use this equation to write some transformations without using our calculator. We know that a, h, and k affect the graph the following way. So everybody take a look at the following problem. Okay, so we are going to write the function rule in the form g of x equals for the following transformations of f of x. So number 1 says g of x is the graph of f of x equals absolute value of x plus 3, translated 1 unit left and 5 units down. Now, we see that this graph is already left 3. So we are going to take, going from left 3, we're going to go 1 more unit left. So it's almost like we're taking the plus 3 and we're adding another 1 to it. And what we end up with is g of x equals the absolute value of x, and then plus 3 plus 1, because it starts 3 left and we're taking it another left. So think about it, plus 3 plus 1 becomes plus 4, and then 5 down. Well, you can see the original graph wasn't moved up or down at all, so we just need to say minus 5. Okay. So number 2 says g of x is the graph of f of x equals, now instead of having an absolute value graph, now we have a square. We have a parabola. But if you remember from the warm-up, not a lot of difference in the way the graph looks. I mean, we have a vertex, and this one looks like a V, and this has a parabola shape. But otherwise, they operate the exact same way. I mean, take a look at the warm-up. It said -1 plus 3, so we went right 1 and up 3. If you had to use your calculator to see it the first time, that's great. But now we know whenever it's -1 and plus 3, it's going to have a vertex at 1, 3. So here we already have a vertex of 7, 1. Okay, so we need to take, so we're already right 7 and up 1. So now we need to take it 2 more units right and 3 more units up. So g of x is going to end up to be, well, if we're already 7 and then we go right another 2, now we are right 9. If we're 1 unit up, we go another 3 units up, now we are up 4. Okay. We've got number 3, g of x is the graph of f of x equals the absolute value of x plus 9 minus 2. So here we have moved left 9. Here we've moved up, down 2. So now we are reflecting over the x-axis. So that tells us that the g of x is going to need a negative in front. Okay. And it goes 5 units to the right. Well, think about it. If you are left 9 and we go right 5, now we are left 4. And it's still going to be down 2. Okay, I'm going to do one more with you, and then you are going to work with your partner on the remaining 4. G of x is the graph of f of x equals x squared stretched vertically by a factor of 3, translated right 4 units and down 8 units. So f of x is like a totally clean parent graph. So we're just going to start plugging stuff in. So first we're going to put a vertical stretch by putting an a value of 3. Now, here it wasn't moved right or left at all, and we need to move it right 3. So we're going to have right 4, x minus 4 squared, and then down 8. So go ahead, I'm going to slide this down, then pause the video and work on the other 4 for a couple of minutes. Okay, the answer to number 5 should be g of x equals the absolute value of x minus 7, and then there's nothing else because it was up 1 and then you took it down 1, so they kind of canceled each other out. Number 6 is g of x equals negative because of the reflection over the x-axis. 5 units to the left, well, now we need a parentheses, x plus 5 squared, and it was up 1, and we're going to take it down 3. So 1 minus 3 is now it's down 2. Number 7 was already reflected over the x-axis, and we're going to reflect it again, so we've kind of canceled out that negative. So it's just going to be 2. And it goes 5 units right. Well, it was 5 units left. So again, those also cancel each other out, and we just have the absolute value of x, and then it's still up 10. And for the last one, we have a vertical stretch by a factor of 3, so that's our a value. It goes left 7. So if it's right 4 and it goes left 7, pull out a number line, do a little counting if you need to. Now we are left 3. And up 10. Okay, I want to take a look at tonight's homework just to make sure everyone is super duper clear. Okay, so this is the worksheet I'm talking about. You need to add to the directions. If they are not one-to-one, you need to give at least one way of modifying the domain of the function so its inverse is a function. If you would like to use your graph for numbers 7, 8, 9, 10, and 11, that's fine. You may do so. I just want to do a quick thing. Number 12. Number 12 is a bonus problem. You do need to produce a graph by hand to come up with that one. So my superstars, please do it. It's kind of a neat little problem. You'll enjoy it. Otherwise, it's not the end of the world if you don't get to number 12. Okay. I'm going to go ahead, pause the video. If you still have time, start the homework. I'm going to turn the page in a second so you can check the homework. And of course, all of this will be on Edline.